Hello dear students, welcome to BioVidyalaya. I hope you all are doing very well. In our previous lecture video, we discussed about Lotka Volterra equation. This is the continuation of that video. Here we are going to discuss about Lotka Volterra zero growth isoclines. This is very important for your CSIR NET examination. So without further delay, let's get into today's class. What is the significance of Lotka Volterra equation? Yes, Lotka Volterra equations are helpful for us to predict the outcome of competition between two species. We can predict what is the outcome of competition between two species, whether it is competitive exclusion or coexistence. Competitive exclusion means eventually one species will eliminate the other species, and coexistence means the two species will live peacefully without any fighting. That is called a coexistence. Okay. So we can predict what is the outcome of competition between two organisms with the help of Lotka Volterra equation. So these are Lotka Volterra equation. We already studied that. This is for species 1 and this is for species 2. Okay. If you know the values of this Lotka Volterra equation, then we can predict the outcome of competition between two organisms with the help of a graph called a state space graph. State space graph. Okay. Here I am drawing the state space graph. This is very important for your examination. So please listen here carefully. This is x-axis and this is y-axis. Here in state space graph, we are plotting population size of species 1, that means n1 in x-axis, and population size of species 2, that means n2 in y-axis. Here you can see one straight line, and this line is known as zero isocline. Okay, zero isocline. Along this zero isocline, population size is 0. That means dn by dt is equal to 0. That's why this straight line is known as zero isocline. And above this zero isocline, that means this side, population size is decreasing, and below this isocline, population size is increasing. Okay, you have to remember that this straight line representing zero isocline, along this zero isocline, dn by dt is equal to 0. At any point along this zero isocline, dn by dt is equal to 0. And above this isocline, population size is decreasing, and below this isocline, population size is increasing. Okay. Based on the equation derivation, we can draw zero isocline for species 1. Okay. Here in x-axis, we are plotting species 1, n1, and here the number of species 2, n2. Okay. And this is zero isocline. In this zero isocline, dn1 by dt is equal to 0. That means population size does not change along this zero isocline. Okay. So let's see what is the Lotka Volterra equation for species 1. dN1 by dt is equal to R1 N1 into K1 minus N1 minus alpha 1 to N2 divided by K1. This is the Lotka Volterra equation for species 1. Okay. So we know that along this straight line, this yellow color line, dN1 by dt is equal to 0. So if dN1 by dt is equal to 0, then we can write 0 is equal to R1 N1 into K1 minus N1 minus alpha 1 to N2. Okay, that means K1 minus N1 minus alpha 1 to N2 is equal to 0. Okay, I think this much is clear for you. Now we can find if N1 is equal to 0, then what will be N2? Then what will be N2? That means here, this point. Okay. So, if N1 is equal to 0, then K1 minus 0 minus alpha 1 to N2 is equal to 0. Okay. Then K1 is equal to alpha 1 to N2. So N2 is equal to K1 divided by alpha 1 2. So this is K1 by alpha 1 2. Here this 0 isocline is intersecting on this y-axis at K1 divided by alpha 1 2. In this time, species 1 is absent. That means N1 is 0. Okay. And then if N2 is equal to 0, then what will be N1? This point. Okay. If N2 is equal to 0, that means K1 minus N1 minus 0. Because here N2 is equal to 0, then this whole value will be 0. So 0 is equal to 0. That means N1 is equal to K1, isn't it? So here this 0 isocline is intersecting at K1. Okay. This isocline on the x-axis intersecting at K1. Okay. So the isocline intersect the graph on the x-axis when N1 reaches its carrying capacity K1 and no individuals of species 2 are present. That means N2 is equal to 0. The isocline intersect the graph on the y-axis at K1 divided by alpha 1 2 when the carrying capacity of species 1 is filled by the equivalent number of individuals of species 2 and no individuals of species 1 are present. That means N1 is equal to 0. Okay. I think this is clear for you. Next is 0 isocline for species 2. Here we know that in x-axis N1 and y-axis N2, and this is the 0 isocline, this pink color line. here dN2 by dt is equal to 0. Okay, this is the point where this isocline is intersecting on the y-axis, and this is the point where this isocline is intersecting on the x-axis. Okay, we have to find these values. Okay, we know that dN2 by dt is equal to R2 N2 into K2 minus N2 minus alpha 21 N1 divided by K2. This is the Lotka Volterra equation for species 2. Okay. So here dN2 by dt is equal to 0. So if dN2 by dt is equal to 0, then 0 is equal to R2 N2 into K2 minus N2 minus alpha 21 N1. That means K2 minus N2 minus alpha 21 N1 is equal to 0. If N1 is equal to 0, then what will be N2? That means this point. Okay. If N1 is equal to 0, then K2 minus N2 minus 0 is equal to 0. Isn't it? Here N1 is 0. That means this whole value will become 0. Okay. So K2 is equal to N2. That means N2 is equal to K2. So this value is K2. Okay. So this 0 isocline is intersecting on y-axis at K2. Okay. Here N1 is equal to 0. Okay. When N1 is equal to 0. Next, if N2 is equal to 0, then what will be N1? Okay. So K2 minus 0 minus alpha 21 N1 is equal to 0. That means K2 is equal to alpha 21 N1. So N1 is equal to K2 divided by alpha 21. So we got the point where this 0 isocline is intersecting on x-axis. That is K2 divided by alpha 21 when N2 is equal to 0. Okay. So the isocline intersects the graph on the y-axis when N2 reaches its carrying capacity K2 and no individuals or species 1 are present. That means N1 is equal to 0. The isocline intersects the graph on the x-axis at K2 divided by alpha 21 when the carrying capacity of species 2 is filled by the equivalent number of individuals of species 1 and no individuals of species 2 are present. That means N2 is equal to 0. Okay. I think this is clear for you. Now we know that how will be the 0 isoclines of species 1 and species 2. But in your examination, you will get one graph. In that graph only, you can find both the isocline, both species 1 and species 2 isocline. Okay, you have to analyze the graph and you have to find who will be the winner of that competition. Based on different competition, there are 4 possible graphs. So let's see that. Okay, first scenario 1, the first case. Here you can find that this is the zero isocline of species 1 because here dn1 by dt is equal to 0. So this is for species 1. Here dn2 by dt is equal to 0. That's why this is for species 2. Okay. Here we can see that species 1 isocline is above that of species 2. Okay. And here you can see that K1 is greater than K2 divided by alpha 21. Okay. And here K2 is lesser than K1 divided by alpha 12. K2 is lesser than K1 divided by alpha 1, 2. So, we can say that species 1 is the winner because its carrying capacity is greater than the carrying capacity of species 2 divided by competition coefficient. So, species 1 is the winner. Okay. And we can rearrange this one also. K1 alpha 21 greater than K2. Okay. Here also we can rearrange K2 alpha 12 lesser than K1. Here now also we can find that K1 is greater. Okay. So species 1 is the winner. That means species 1 is strong competitor. It is showing, this species 1 is showing strong interspecific competition. Okay. That's why species 1 is the winner here. Next, scenario 2. Okay. So here dn2 by dt is equal to 0. So this is the isocline of species 2 and here dn1 by dt is equal to 0. So this is the isocline of species 1. So species 2 isocline is above that of species 1. Here you can see that K1 is lesser than K2 divided by alpha 21. Here I am writing K1 is lesser than K2 divided by alpha 21. And here K2 is greater than K1 divided by alpha 12. K2 is greater than K1 divided by alpha 12. So we can say that species 2 is the winner because the carrying capacity of species 2 is greater than the carrying capacity of species 1 divided by competition coefficient. We can rearrange this also. K1 alpha 21 lesser than K2 alpha 12 greater than K1. So here also we can see that the competition coefficient of species 2 is greater, isn't it? And carrying capacity of species 2 is also greater. So we can say that species 2 is the winner. Species 2 is the winner of this competition because species 2 is showing strong interspecific competition. Okay. Species 2 is strong interspecific competitor. So, ultimately, species 2 will win and that will eliminate species 1. Okay. So, this is the graph of competition competitive exclusion. Okay. Here species 2 is the winner. Okay. Third case, that means scenario 3. Here you can see that these two isoclines are crossing here. Isn't it? This is the isocline of species 2. Okay. Here I will mark as in red. This is the isocline of species 2 and this is the isocline of black color one is the isocline of species 1. Here dn1 by dt is equal to 0 given. So this is the isocline of species 1. Here both the isoclines are crossing, isn't it? And here you can see that carrying capacity of species 1 K1 is greater than K2 divided by alpha 21. I will write here K1 is greater than K2 divided by alpha 21. Here K2 is also greater than K1 divided by alpha 12. Okay. So both the species have strong or greater carrying capacity. Okay. Carrying capacity of both the species are greater. Okay. We can rearrange this K1 alpha 21 is greater than K2 and K2 alpha 12 is greater than K1. Here we can see that competition coefficient of both the species are greater. That means both are strong competitors. Both are strong interspecific competitors. So, we can't predict who is the winner. Both the species have chance for winning. We can't predict who is the winner. That is depending upon the environmental condition. So, this is the graph for unstable coexistence. We can't predict who is the winner because both the species 1 and 2 are strong competitors. Okay. Eventually, species 1 or species 2 will win. Okay. Scenario 4. Here you can see that both the isoclines are crossing here. Isn't it? This is the isocline of species 1. Okay. This one is for species 1. And this is for species 2. Okay. Here both the isoclines are crossing. Okay. And we can see that K1 is lesser than K2 divided by alpha 21. I will write here K1 is lesser than K2 divided by alpha 21 and here K2 is also lesser than K1 divided by alpha 12. K2 is also lesser than K1 divided by alpha 12. So here carrying capacity of both the species is lesser than that of carrying capacity of other species divided by interspecific competition coefficient or we can say competition coefficient. Okay. So we can rearrange this one. It will come like this. So we can say that both the species are weaker in competition. Both the species are weaker in competition. They are showing weaker interspecific competition. So here interspecific competition is lesser than that of intraspecific competition. So there is no fight between two species. They are coexisting at stable equilibrium point. Okay. So this is the graph of stable coexistence. Stable coexistence. The last graph was unstable coexistence. This is stable coexistence graph. Here both the species are living peacefully without any fighting. Okay. The four graph altogether given here, you have to remember that above the isocline, population size is decreasing, and below the isocline, population size is increasing. Okay. Parallel isocline represents competitive exclusion. Here we can see that these are parallel isocline, and here species 1 wins and population size equals carrying capacity. Okay, ultimately species 1 will and species 1 will eliminate species 2. Okay, and here you can see that species 2 wins and population size equals carrying capacity K2. Okay, ultimately species 2 wins and species 2 will eliminate species 1. Okay, and crossed isoclines represent coexistence. Here you can see that these are crossed isoclines. This is for unstable coexistence and this is for stable coexistence. Okay, I think this is clear for you. Here I am winding up this lecture video. If you find this video was helpful for you, then please click the like button, share this video with your friends, and also don't forget to subscribe this channel and turn the bell icon to all. Then only you will get the notifications of all the videos. So keep learning. Thank you.